Ready to effortlessly conquer those tricky statistics problems? Meet ShinStats. Picture having a personal statistics wizard in your pocket, leading you step by step through the toughest questions. Hey Nixers! Ever wondered how to forecast a value using the exponential smoothing method? Today, we're about to unravel that mystery. Join me as we calculate the exponential smoothing forecast, the mean squared error, and the mean absolute percentage error. All right, Nixers, got a question for you. Now let's proceed to the calculator and crunch the numbers. Begin by launching the app. Head to the menu bar and click on it. And here's a quick pro tip. To make things even easier, use the search bar. Just type exponential, and it will lead you straight to the calculator. To initiate the forecasting process, we begin by entering values for the time variable, which, in this context, is represented by the week column in the provided table. Observe that we limit the forecasting analysis to week 9, as it represents the last week for which paired demand values are available in the dataset. Simultaneously, we input the corresponding actual demand values found in the demand column of the table. Moving forward, we introduce the smoothing constant, denoted as alpha, into the forecasting model. For this particular scenario, the given alpha value is specified in A as 0.10. This parameter plays a crucial role in determining the weight assigned to the most recent observation while smoothing out fluctuations in the data. The next step involves providing the initial forecast value. There are two instances where we can leave this input as blank. In this case, we are directed to assume that the initial forecast value is equal to the first demand value in the dataset. It is important to note that, in certain scenarios, no specific initial forecast value may be provided. In such instances, the initial forecast value can also be left blank. Remember, accuracy is the key. The app's magic works best with precise data. Now, we're ready to unleash the statistical wizardry and proceed with the calculation of the exponential smoothing forecasts. With everything set, we now click Calculate and wait for the app to do its magic. Interested in downloading the app? Link in my bio. All right, Nixers, let's delve into the step-by-step solution. We'll walk through each phase, providing a sneak peek into what the calculator churns out. In step 1, we calculate the forecast values using the following simplified equation. Basically, this means that to calculate the forecast value of the current week, we need to multiply the smoothing constant alpha to the actual value of the previous week, and add this value to quantity 1 minus smoothing constant multiplied to the forecast value of the previous week. We can observe these calculations in the last column of this table. Remember the input box that we left as blank a while ago? We can observe its effect in the first row of this table. Notice that the first forecast value is equal to the first actual demand value. Moving on to step 2, we calculate the forecast errors. Here, we subtract each of the forecast values from the actual values in each row. Observe that in this column, forecast errors can either be negative or positive. Since we assumed that the first forecast value is equal to the first demand value, the error and all subsequent parameters for the first row in the calculation table are left blank. In step 3, we calculate the absolute errors. In simpler terms, we force the values of the errors to be positive. As a result, in this column, we see similar magnitude of values to the previous column, but this time without any negative sign. Moving on to step 4, we calculate the mean absolute deviation. Basically, we add all absolute errors found in the last column of the previous table, and then divide the sum with the total number of absolute errors, which, in this case, is equal to 8. This is also the reason why leaving the first row as blank is particularly important. If there was a specified initial forecast value, we would have had an absolute error in the first row, and this, in turn, will result to an increase in the value of the denominator from 8 to 9. In step 5, we calculate the squared errors. From the term itself, we raise each of the absolute error values to an exponent of 2. As a result, we have the following calculations. Now, what do we get if we add all these squared errors and divide by the total number of squared errors? It would be the mean squared error, which is calculated here in step 6. Now, in step 7, we calculate the absolute percent errors. APE. Basically, we divide the absolute error by its corresponding actual value in the same row and multiply the result by 100%. As a result, we have the following calculations. And since we are already in a pattern of adding everything and dividing by the total number of something, we arrive at the calculation of the mean absolute percent error in step 8. Lastly, to calculate the forecast value for the next succeeding point in time, which is week 10, we use the same equation for the forecast value and determine the demand value for week 10. Can I interest you in an opportunity? Notice that we did not do any calculations related to a smoothing constant alpha of 0.60. Will you be interested in using this calculator and compare the resulting values for the MAD, MSE, and MAPE? Which exponential smoothing method is better? Is it the one with the smaller smoothing constant value or the one with the larger smoothing constant value? Drop your answer in the comments. Your input is the key to knowing if we're making a real impact. Let us hear your thoughts. Did those results light up a spark of curiosity in your mind? Show some love with a double tap or hit that like button. If you're itching for more data-driven excitement, click the link in my bio to download the app from the Google Play Store. A heartfelt thanks for sticking with us till the end of the video. See you on the next one. Follow for more.